Finally, let's analyze our structure and consult its results. For that, we're gonna have to click in the analysis menu, and the first thing that we find is the nonlinear combination settings. I recommend to check out the possibilities. These more advanced possibilities are not a goal of this training, but we do have learning resources about the nonlinear analysis and backplane analysis, as well as the model vibration analysis. So please ask for them if you cannot find them, or search for them in our different platforms. We're going to run the analysis, and we're going to first comment a little bit because we have, even for the linear analysis, we have some design options. So here we find that there's the possibility to just check the sections that we have set and inserted, or we can have the software quick section design and optimum section design. You can know all about the difference between these two design options by clicking in the book help and just reading the text when you place the cursor over each option. In this case, I have already pre-designed the sections, and I'm happy with the ones that we inserted. So we're not going to have the software design them for us. Do not dimension sections. We're going to ask for the check of the parts, and in this case, since we haven't inserted generated the joints yet, we are not going to consider in this analysis, as I said, yet the finite dimension of the nodes. I will make sure I point this out in the video where we speak about the generation of the joints. So we're just going to click accept, and in a few seconds we will have the final design report, in which the only thing that is listing is that the fire check option has not been activated. We know this, we have done this on purpose, so it's okay. We're just going to close the report, and we are going to have many options now active here in the stress and strain analysis menu. The first result that it's here to consult is the displacements and rotations in the bars. So this tool, we can consult the displacements in the bars either by simple load case or by combination. If we select the material, we can search for them by combination, and just by clicking in any bar, it will display the displacements and the rotations of this bar in their two ends. The envelope means display the maximum and minimum displacements of the nodes, even if they don't come from the same combination. I suggest reading this text over because we get asked a lot in when we answer the support questions. But basically, if we select envelope, we are making sure that we don't know from which combination it came from. I mean, the minimum and maximum value do not come from the same combination, but they are the maximum and minimum displacement that this bar is going to suffer. Next up is the reactions. So in each external fixity, we can consult again by simple load case or by combination the reactions. Usually the data that we send to you, we're going to, in another video, we're going to see how to analyze the foundation here inside CYPE, but just know that usually software which are for the analysis of foundations do their own combinations, so they usually ask us the enter input data for the simple load case. So this is one way that we can consult them. We could also consult their reaction in their reports. We will talk about the reports in a minute, so I will make sure I point out where the reactions are listed in a report. Another tool that we have in the results is the forces. So we can consult the force diagrams in the bars, again by simple load case or by combination. And in this case, we are going to display just the self-weight of the moment in Y to comment some results. Usually the scale is in 0.0, but just know that by entering any number, we can scale up so we can see bigger diagrams over the bars. Now we have selected force diagrams in the bars that we click only and consult values. So if I ask, for example, the moment in Y of the self-weight of these bars, I can clearly tell that we have pinned the ends of this bar because all that we have is positive moment in Y. But in this other bar, for example, that we fix the ends of, we can tell by displacing by sliding their cursor over the bar, the values, because we have this option consult values activated, otherwise this sort of tag that comes up won't be there. Let me demonstrate. So if I hide it, I can still see the maximum and minimum values because I have this other option active, but unless I click here in consult values, when I'm sliding the cursor over the bar, I can consult that in this part we have a little bit of negative moment in Y. Afterwards we have a long length in which we have positive, and then again when we come to the other end we again have negative moment in Y. Another tool that we can use is the deform shape and contour plot. So in this case the deform shape of the structure will be displayed. Again, same options, maybe let's select 1 by 10s and just scale this up a little bit, maybe by 50. I'm going to exaggerate it a little bit more, let's say 100, and I can play the values of this displacement for this combination are now displayed by color, and the color corresponds to either one of these values here in the bottom part of the screen. But we can play this animation to see the deformed shape. So this might not be the best combination to see it, but allow me to display this other one so we can see in an animation how the structure is going to deform. We exit the deformed shape to see now bottom plate distribution. In this case, we didn't insert any bars that would have bottom plate, but I have a copy of our structure and I have changed the sections used for the columns. So allow me to describe them so we can see together that besides the types of materials and the plenty of sections that the software has, even for a same section as the rolled eye, we have different possibilities. The ones that we use for a simple section, but just know that, for example, we have other possibilities of section even in Y, making it double in box with button plates, for example, in this case. And we can already tell that they are double in this 3D view of the work area, but I have already analyzed this copy, and by coming here to project, we can display another type of 3D view of the complete structure, and those elements, and for example, when we insert the connections, the joints, they will be in this 3D and not in the 3D view that came by default. So here we can see the possibility of creating sections with button plates, and of course they will have their own results as what is the separation that they shall have, what are going to be their thickness, what's going to be the shear and its length. And for example, I have also added hunches to this other beam. If you can tell here, that was done exactly the same. Instead of choosing a simple section, I chose the second simple with hunches, and I inserted them in the bottom of the bar. So coming back to our example, we have two more tools, actually, in my opinion, very strong tools in these results of the analysis, and I'm going to comment them in the way that I usually use them. This I usually treat as a quick check. So check elements, it's a tool that's going to allow us to, in one just quick view, see if there are some elements that are there's something wrong with any elements. Usually elements with issues will be displayed in red. In this case, our bars, as we're going to see in a moment, are over dimensioned, so there's no problem with them at all. That's why they are all displayed in green. So let's see some things that we can consult in these check elements. If I place the cursor over any bar, there's a box. Please notice this part of the screen. There's a box that comes up that says the reference of the beam. It tells us which section it is. It tells us the DC ratio resistance by percentage. So we can see that this bar, for example, being in a 18, almost 19% of DC ratio resistance, is over dimensioned. Probably a section smaller than this one would pass all the checks too. And please notice right underneath it, we have the DC ratio of deflection. Remember that this and this other one were the only bars that we established the deflection limit for. So when we come to any other bar in this model, I can ask for the resistance ratio, but not the deflection, because we didn't set any limits. So here in the deflection, it says no limit has been defined, and instead here we find. Next, it tells us again that we haven't carried out the fire resistant check. And if we click on the bar, instead of just placing the cursor over it, we can see a list of the sections from the same series that this section came from, the HEA. And we can see that, for example, the first 4 sections up to 160 wouldn't have passed the checks because of deflection. Afterwards, for resistance, both of these first failed, both for resistance and deflection. These two would have passed for resistance, but not deflection. And then the first bar that we could start to consider would be the 118. I have thought about it, in the 180, it's too little. It's 180 millimeters, so 18 centimeters of of section, and I found it too little, so at least I'm going to go by the one that we said, which was HEA 240. But if I wanted to change it, I could change it by double clicking. This section would be changed, but we will have to run the analysis again to see if it passes or not the checks. So that's one quick way to see what's going on in the bars, but a more in-depth look at what is going on is this next tool. It's called ULS Checks, and if we click in any bar, we can ask for that ULS check report. So it is step by step, fully transparent on the values that the software has used for the analysis on every code check for the code that we have selected. So for example, here we can see the combined bending and axial resistance. We can see the formula, which combination is using and which values, and we can double check what the software is doing at all times. This report can be either checked like this, code check by code check, or we can ask for here the view of the complete listing, and this report can be exported to multiple formats, clicking here in export. So it tells us first this section of the bar and its mechanical characteristics, and then starts listing all the code checks. Another way that we can consult reports is either by asking for the reports of the full structure, which would be done in these icons right here. I found the reports and the drawings, for which we'll comment in another video. So here in the reports, we find the possibility of asking for reports of the full structure. For example, when this comes up, this might be just a warning. Like in this case, we can actually ask for the details on what is going on, see details, and in this case, what is warning us is that the automatic generation has been deactivated for the braces. Remember that we did that on purpose. So we're just going to click accept and access the this list of things that we can ask for. So by clicking here in all chapters, we can deactivate the values or the things that are selected by default. And for example, coming back to what we said, we can consult in the notes the reaction either by load case, which is the thing that the software usually use for then the analysis, or by combination or envelope. So let's say that we wanted to have in our report the reactions by load case of our structure. We could ask for all of them, all of the external fixities reactions. So here is node number 1, 3, 5, 7, 9, and 11. But how do we ask for a report on specific elements? Well, that is done with this other option. It's called selected elements. So if I select this option and select, for example, this bar, I can ask for the list depending on the element of forces results of the bars, and I could, for example, ask for the forces in a report and ask for the envelope. Or maybe here in results of the beams, ask for the just the ULS check and reports and click accept. So I can have either reports of the entire structure or by selected elements with that other option. Of course, every report can be exported to multiple formats. And I think this is it for these results of the analysis. See you in the next video.